Everyone, we're gonna get going here in just a few minutes while everything gets started. How's everybody doing? Drop us a hello in the chats. I'll say hi. Sorry for the sirens, they're on my end. Sirens going by outside. Windows open because it is kind of warm in here. All right, do we have folks? Are we working? Oh yes, YouTube says 9. Johnny's typing. The delay might be a little bad. Hi, Johnny. I should have auto captions on, which definitely which requires you to be on the slowest kind of setting for streaming. But I do like having it. Hi, Sam. Thanks for joining. I think you found, was last week your first deep dive? We are live, says Johnny on YouTube. Let me put lotion on while I wait. Oh, thanks, Johnny. I appreciate it. I'll tell you, I am ready for the weekend. Hi, Beata. Thanks for stopping by. Yeah, last week. Awesome. We'll wait one more minute and then we'll get going. How's everybody's weekends shaping up to be? I think I tend to be the last person to hit weekend here in the Pacific time zone. Got these European folks. Hi, DCD. All right, let's get this show on the road so I can get on the weekend afterwards. I like streaming. But yeah, we'll talk about what I'm working on. But first, hello everyone. My name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python, which is a good beginner programming language that's designed for microcontrollers. So what I have here is, this is called a clue. It's in the shape of a microbit. But on here, underneath this little canister here, is a little tiny computer called a microcontroller that runs a version of Python designed to run on these inexpensive computers. So if I just take this battery and plug it in, we'll see that on the screen, CircuitPython is showing its output. So CircuitPython is what's known as a firmware that goes on these little tiny computers and allows you to program them to do all sorts of small tasks. Adafruit makes development boards generally and breakout boards. So this is an Adafruit board. So the microcontroller itself is not made by Adafruit, but assembling all these components on the board, designing and assembling boards like this is what Adafruit does. So they pay me to work on the software side, the CircuitPython software side, which is even though it implements Python above, it's mostly C code below. So we do a lot of technical deep dives into things like USB and C and all sorts of stuff. So that's what these streams are. They're usually Fridays at 2 p.m. Pacific. I can't remember, I guess I streamed last week too, but the week before that I took off. Foamy Guy also will do deep dives, and he generally does more like Python level stuff, which is also interesting. So if you want to support me doing these streams, I'm paid by Adafruit to do all this work. So you can go to adafruit.com and purchase a board like the Clue, although I don't know if it's in stock. Hopefully it is. And that supports the whole company of which I'm part of. Beata said, looking forward to USB going main. Do you mean USB host? And if you want to join the Discord, so there's 2 chats on this side. The middle one is Discord server. This is a chat that doesn't disappear at the end of the live stream. There's lots of folks there that are super helpful. So if you want to join that, you can go to the URL adafru.it/discord. And that will get you into our Discord server where I hang out during the work week along with the other folks that work on CircuitPython, but also a larger community of folks that are super helpful and doing cool stuff as well. So that's the intro. So I put on the title here that I'm working on PyCascades. So PyCascades is a regional Python conference. It switches between 3 cities: Vancouver, Canada, Seattle, Washington, which is where I live, and I work remotely for Adafruit, and then also Portland, Oregon, which is south of here, about 3 hours drive. So this is a year where PyCascades is in Seattle, which I really have no excuse not to participate in. I do have a 2-year-old. He turned 2. So it is hard to get to other cities right now, but PyCascades is in Seattle. It's where my alma mater. So I went to the University of Washington, and that's where the conference is this year. So I applied to give a talk, and they accepted it, and so I'll be giving a talk on Sunday, the 7th. And I've been meaning to put my slides together. And I got an email from the PyCascades folks that included the reminder that they want to look at slides ahead of time to make sure there's no copyright issues, because they're going to post all of the videos to YouTube afterwards. Which means I thought my deadline was the 7th when I'm giving the talk, but it turns out it's actually a week earlier, this Sunday. So I realized that Wednesday night. So I spent all yesterday and then this morning working on a slide deck for this talk that I'm going to give on Sunday. So spoiler alerts, if you do want to come see the talk on Sunday at PyCascades or watch it later, I plan on just talking about it today and working on it today. I am running out of steam. I will tell you, I'm running out of steam to work on this. But I need to get it close enough that I can send it to them and be, close enough. I understand there's copyright stuff. And so yeah, that's what I've been working on. I'm excited to do it. So the talk that I pitched is called Cutting the USB Cord, Programming CircuitPython Wirelessly, or Wirelessly Programming CircuitPython. And the reason that I applied to do that is because in the last few versions of CircuitPython, we've removed the restriction we had originally where we only did native USB boards. And we created both what I call a BLE workflow and a Wi-Fi workflow, or a web workflow, that allow us to program CircuitPython wirelessly. And those things, web workflow is getting more pickup than the Bluetooth side. But they each have their advantages, and so I wanted to take this PyCascades opportunity to really show people how to use them, because we don't have a lot of people using them, and when you don't have a lot of people using something, it's easy for the code to stop working, which to be honest I've been running into, which is part of the reason I'm kind of a little burned out on it, is that things that used to work don't work anymore. Some of that's my fault, and some of it's just that, who knows what. Which is kind of what the conclusion of my talk is turning out to be, is we have this chicken and the egg problem with these workflows, where if nobody uses them, they can break and we won't realize it. And the longer it takes for you to realize that something's broken, the harder it is to fix, because you don't have the context of what's changed recently. So you want more people to use it so that you can find issues when they happen, but also people aren't going to use it if there's too many issues. So there's this chicken and the egg problem with bootstrapping stuff. I think the web workflow kind of has gotten over that hump. I think enough people find it really convenient that they're using it. And I'm hoping that actually like the web workflow will actually bring more people into the BLE and the mobile landscape, as we'll see. One thing I didn't say yet, but I love to answer questions, and I'm kind of burnt out on working on this presentation. So if folks have other questions about CircuitPython or electronics or software, feel free to ask them, and it'll give me a nice break. So I'm just going to try to see how we're doing here. All right. So yeah, I have a lot of more work to do on slides. It's a 25-minute presentation. David says, any plan for Mickey Mouse, the very old image of them in the presentation, because it's out of copyright? And the answer is no, I don't want to go there. I don't need to push that limit. So I can just show you what I've been doing. I think I've got, I thought I had a second. How many Firefox windows do I have open? Not enough. I thought I had one here. No, I guess not. Sorry, I want to show you the presentation where I'm at so far, if nobody has questions. DCD says the Memento supports web workflow also, right? Correct, it does. And one of the reasons I want to do BLE on ESP is also to support the BLE workflow through the ESP32S3 as well. So let me show you what I have so far to give you an idea of where I'm going with it. So technology-wise, I should also plug. What am I thinking? Hold on, let me find oh, I know how to find it. Sorry, I'm trying to find this video. So, yes, I'd love to be distracted by that. Oh, I should say, I have my PyCascades 2020, PyCascades 2020 shirt on. So that's the last one I've gone to, and the last one I spoke at was PyCascades 2020. It was in Portland, and it was February of 2020. So it was like right before the US really got hit by COVID. I think there's like kind of like a collective amnesia about what happened there. And I just wanted to plug, I think I plugged this on this before, but I actually split it out. So this is the talk I gave at PyCascades 2020. It's like super broad, big vision, but I'm really proud of it. And now I've actually split it out so that you can watch the talk. It was the last talk of the day, which was interesting, and and it feeds into it's the reason that all this mobile stuff matters to me so much. Basically, the thesis is that like people's first computers are no longer laptops or desktops; they're mobile phones. And so, us having a story for how do you do CircuitPython with a mobile device is like super important to me, because that's how we get people from being consumers of code and software on their phones to actually creating software, which is like a tricky space. So yeah, it needs a lot of work. Okay, before I get started, Sam asked about, could you talk a little bit about what you're imagining building with Clang might look like, other than just a string replace of GCC with Clang? So yeah, so this comes back to the Honcho stuff a little bit, which I'm happy to venture over to a little bit. CircuitPython Clang 18. So this is my working branch. And I've had, yeah, we talked about build systems a couple weeks back as well, but my background is that I used to work for Google way back. I left in 2015, so it's been, I guess, almost a decade, which is insane. But one of the things that they did when I was there was I was working in C++, and they switched us over to LLVM and the LLVM world in Clang. And the tooling, the error messages got a lot better. The tooling around it got a lot better. And so I've always had this in the back of my mind that I'd like to switch us to Clang in CircuitPython. The other reason, a newer reason, is that I really want to have a compiler and linker that I can modify and make work better for embedded and CircuitPython in general. So those are kind of like two of my motivations. And then another thing that I've been thinking about is how to switch, how to have a better build system for CircuitPython where we can structure it in a way that we share a lot more things. There's like, right now the build system is all makefiles. And the kind of like top level makefile is at the port level, which is like the chip family level. And then there's a bunch of settings that can be set at the port level and the board level, and then at the global level too. But I'd really like to move us to a world where, one, we use Clang to do all of our builds. So we have one compiler that works for all of the boards. One neat thing about Clang is that the Clang binary itself is built in a way where it can do like both ARM and RiscV at the same time. You don't need different binaries of Clang. So yeah, the tooling around Clang is really good. In fact, I talked last week about how I went down the rabbit hole of thinking about a new editor. And newer editors have things called language servers, and language servers are the thing that drives like completion and warnings and stuff. And the one that is installed by default for C is actually Clang D, which is like a daemon version of the Clang C compiler. So I think there's a lot of reasons to do Clang. Being able to modify it and make it work better, having our warnings align with like the warnings that we would get from a language server. The formatter could be the same. There's also Clang Tidy, which is doing more structural analysis of the code. So yeah, so there's that. And then on the build, I know I'm brainstorming or brain dumping, and then on the build side, there's also that when we build each board in kind of a silo. So we like make a build dashboard name, and then we build all of the files under that directory. There's no sharing between boards, sharing of work. And so for the build system, I'd really like us to move to a world where we stop doing that. So we can actually, well, at least maybe initially we do, but as we, over time, ideally we'd be able to factor like computation out so it can be shared across boards. For example, like we've talked about QStrings. Andrew says, was a great talk. Oh, thank you. Yeah, I'm really proud of it. Some people say they can't watch themselves again, but I actually, I've gotten over that. And I'm really proud of that talk. So yeah, I have this kind of intermingled goal of like having a build system, a new build system, and switching us to Clang. I could theoretically just do this Clang to switch, but then the Clang switch, and I've tried that, but there's a lot of like, it adds another layer of like mechanics to the makefiles that are not easy to understand already. And then the other wrinkle that, so Sam was thinking about this too, is that with RiscV, there's a lot of little like subsets of instructions that like certain CPUs will implement or not implement. They criticized ARM for this, and then they made it worse, in my opinion. Like they said, yeah, I'm not sure that they're just doing it a different way. They still have the same problem. The same problem being that like different RiscV CPUs can have different sets of instructions. David says, you say Clang can be modified, but your current compiler cannot be modified. I think the general wisdom in compiler circles is that GCC is less well organized than Clang is. So there's reason to learn Clang over GCC. In addition to that, my philosophy when it comes to licenses is that you're actually going to have more collaboration for folks for liberally licensed things than virally licensed like the GPL. But it's because a lot of people that are paid by companies are really wary of doing GPL stuff, unless it's really, really valuable, like the Linux kernel. So yeah, that's kind of where I've always wanted to switch to Clang because I have this like positive experience with it. Then on top of that, like being able to modify it is nice, and having good documentation about it. I've never looked at modifying GCC, but yeah, I looked at modifying Clang and I figured out how to do it. So the other wrinkle in this, and I ran into this, I've tried to switch CircuitPython to Clang a number of times. That's why this is a Clang 18 branch, so 18 is the latest version. I also have a Clang 16. I have a regular Clang branch, so I've been trying to do it for a number of years. And I've always run into the issue that not only do I have to install Clang, but I actually still have to install arm-gcc-none, which is really unfortunate. And the reason is that even though you're not using the compiler, you still need like all of the libc and the compiler runtime libraries. And in a world, especially with RiscV, where like your CPUs can have any mix of things, finding somebody who's like built all different combinations of those libraries is like not trivial. So another reason that I've gone into the rabbit hole of like I'd rather have a new build system is that I think what in my mind we'll do is we'll just use Clang as a compiler and we'll build literally everything else that we need. So we can get source code for everything else, both the like libc, either new libnano or picolibc, or the LLVM project is working on like libc that's all. Some of those libc implementations include assembly code, which makes it really hard to be portable, right? So you need assembly for every different instruction set. But if you write it all in C, if you write libc and all in C, then you can just use the compiler to go from one CPU to another. So I think what I would like to do is, like in the long run, a board says what microcontroller it is. The microcontroller knows what instruction set architecture it is, including if it's like a RiscV, it knows exactly which RiscV extensions it's included. And then it just builds everything. So it builds libc, it builds the compiler. So in GCC land, there's libgcc, which is like the library that GCC assumes that it's linking against. And then in Clang land, it's called compiler runtime. So it's like, they have this notion of like, we're gonna have some set of functions that will link against. So like memcopy, memset, like it assumes that there's already implementations of those things. And those implementations, I guess those are libc, I think. But yeah, anyway, usually when you get a compiler toolchain, part of the toolchain is actually some library code that's already been precompiled. And I think for CircuitPython, I'd rather standardize us to Clang and then build all of those libraries ourselves, because we can get the source. It's just not typically how it's done. But the advantage is that like we had this issue for a while where CircuitPython, when I built it on my computer, would have more free space than in the CI. And what we figured out is that the libc implementation that comes precompiled with my version is compiled with -os, which is optimized for size. And then the version that shipped with like the Ubuntu packages for arm-gcc was compiled with -02. So, which is like for speed, but not size. So, and then you also have this like, is it floating point? Is it not floating point? You have this question of like, are you doing LTO, link time optimization, or not? So in my mind, you get a lot of benefits from being able to just like say, I'm going to just compile all the source code and I'll apply these like optimization settings based on what I want for a particular board. And like, it's not all that much source code. I don't know exactly why they get shipped with the compiler. I think the reason might be that you need to make sure that you're matching, that your versions are matching. So like Clang 18 needs version 18 of all the compiler runtime or something, right? I think that might be why it's shipped. Same with GCC. Sorry. I don't know if you can hear the fire extinguisher thing going off. Oh, let me go to window cam. Can we see it on window cam? Just barely. See that steam in the bottom right? Window cam. So that's what the noise is. So that store out my window is a fire, fire extinguisher sort of store. And I think what they do sometimes is they have to like discharge them, and so they have these pipes that go out to the ceiling. Anyway, what a tangent. Anyway, that was a brain dump about build systems and compilers. Does that make any sense? Any questions about that before I get off that topic? I mean to get back to it, but I really got like, oh no, I really have to work on my slides. Which I do. I really do. Because I don't have that much time this weekend. I got to send them something on Sunday. I've got like 50 slides done. It's going to be a quick slide talk. Yeah, that's great. Thanks. Awesome, Sam. I think it's really exciting. I think it's really potentially cool, especially because we were talking about CircuitPython on FPGAs with soft cores. It's like we could, if we had that ability to basically compile all our libraries for a particular CPU, we could do a lot of experimentation in the FPGA landscape of like, oh, well, if we add this RiscV extension, suddenly like it gets this much faster. I don't know, maybe not. Build the builder, that's a lot of work. So I'm not saying that we're going to compile the compiler. We're not going to do that. That's not what I'm proposing. I'm proposing we compile the libraries that the compiler uses, which they're not too big. Like I got Clang PyCascades building, which is like the libc stuff, and it was like 170 targets, 170 C files that it's compiling. It's really not that much. So I think that like, yeah, I think it's the right way to go. Not building the compiler, but I'm building the compiler's libraries that it usually ships with. They're not that big. Okay, let's talk slides. I got work to do. I worked all day yesterday on it. So, the way that I'm going about this is, so my goal is to, what about the SDK from Espressif? Does that come pre-compiled and just linked? Parts of it are pre-compiled. There are binary blobs in the Espressif SDK, but we do compile a lot of it too. And interfacing with like their CMake build system is kind of interesting to think about as well. But yeah, we wouldn't necessarily be able to do absolutely everything. Like we can't recompile that precompiled stuff. Okay, let's go back to the beginning of this presentation. So I'm using a thing called marp. My previous talk that I linked to, I did using deckset, which is like a paid program that goes from markdown to slides on Mac. And I don't run Mac every day anymore, and so I wanted to find something else. DC just says, you mentioned bare metal Raspberry Pi. If there were a bare metal Beagle 5 Fire, one could get an FPGA included. Oh, yeah, I think I know what you're talking about because there's a hard RiscV CPU with the FPGA next to it, right? I've also looked at the Zinc chips from Xilinx because they have hard Cortex A's next to FPGA fabric. The one that I've been targeting is or in my mind is the one that we would do is the ECP5, which is on the Orange Crab. The Orange Crab is in a feather form factor, so it like fits neatly into the Adafruit ecosystem. Okay, so let's maybe go through this talk a little bit. I think maybe part of the reason I'm like not wanting to work is that it's 78 degrees in here. Maybe let me get the fan going. Maybe that'll help. I could do AC, but the AC is pretty loud. I'll be right back to the mic. Hopefully that'll help. Hi, Gary. Not trying to distract you. Oh, come on. You know I want to be distracted. Okay, so it's cutting the USB cord wirelessly programming with CircuitPython. What dark magic is this? It's called Bluetooth and Wi-Fi. So let's just go through what I have so far and we'll figure out what I need to add. Hello, I'm Scott. I work for Adafruit. I go by Tannewt online. Let's get started. So this is a clue. It's an Adafruit board. It's shaped in the kind of microbit educational space. It's got a screen on the front and some buttons. On the back, it's got a USB plug. It's got a microcontroller, which is what's under this lid here. It's a little tiny computer. It's 48 megahertz, 256K RAM. So microcontrollers tend to be like in the tens to hundreds of megahertz. We're very much in the like the Moore's Law sweet spot still for getting more faster chips for cheaper. Then the last thing I want to point out on here is that there's an antenna up here. So this board also has Bluetooth capabilities. So I want to get CircuitPython on this board. Hi, Hams Labs. Just got here, no problem. All good. So I want to get CircuitPython on this clue. So we're going to go to circuitpython.org. Once you go to circuitpython.org, you click Downloads in the top left. We have 490 boards supported. You can see these. Dexter never got a clue. It's not too late. You can still get a clue. You can see here that we have 490 boards, so it's easiest to find a board you want by typing into the search box. The top 50, I think, are sorted by popularity. So these are our most popular boards by download count. And then everything else, I think, is alphabetical. So you can type in here. You can say, "Oh, I want a clue," and then you can click on that page. Once you're there, you can hit Download UF2 now. This is a kind of USB-friendly format for the CircuitPython code, or CircuitPython binary. Now that you have that, let's plug in our USB. And we'll plug into the clue itself. And once we have the clue plugged in, we're going to want to double tap the reset button in the top right there. And once you have the bootloader going and on USB, you'll get a nice green light here. Once you get a green light, you can go into your file browser and you drag your UF2 onto the clue boot. Generally, in the USB bootloader land, you'll have some name that ends in boot where you drag it to. After you drag it there, it gets copied over, and the microcontroller will restart. And now what you'll do is you'll get a CircuitPy drive, and on that CircuitPy drive, you'll have a code.py. This is your CircuitPython code. Once you have your CircuitPython code, you can double-click that to open it in your editor. By default, you'll have hello world there, print hello world. You see it looks like Python because it is Python, but it's the device that is actually storing the human readable version of the Python code, parsing it, and executing it all on the device. So all I need is a text editor and saving to the USB drive. One thing I do need is I don't see any output. So how do I get the output? Well, one way is to open your console. I like TO as a terminal connection. You could also use screen. And I also want to highlight that on Linux, at least, you can do this dev serial by ID USB dash, and then it'll be the name of the device, which is really helpful. So once you're connected to the serial link through TO, it will reconnect. Does DigiKey have it in stock? It's out of stock at Adafruit. The nice thing about TO here is you can see that it reconnected for me. I connected once, got disconnected actually because I zapped, I zapped the board and it reset. My office here is super bad for static electricity, which I need to come up with a plan for because I'm gonna kill some of these electronics at some point. But yeah, that's why it restarted. But also, if it says it's connected but nothing showed up, you may actually have to Control-C the existing code because it may not be outputting anything. So if you Control-C, you can type a character, you'll get to the REPL. Lots of love for TO. Yeah, TO is great. I agree. Timestamping with TO is really handy. You can do Control-T to toggle how it timestamps stuff. So if you actually want to time the duration between prints, it's actually really helpful, which is cool. So if you're in the REPL, you can type whatever you want, but you can also do Control-D, and once you hit Control-D, you'll get your serial output. So you can see here, code.py output is hello world. So now if we go back to our editor and we change that to hello PyCascades, and you can see it's unsaved, we'll hit save, and once we hit save, the text or the serial console will show hello PyCascades as well. So what did we just do? I introduced you to CircuitPython and the way that CircuitPython typically works. This is what I consider to be one of CircuitPython's workflows. And that happened to be the USB workflow, which is one that we kind of focused on for the first 6 major versions of CircuitPython because it was so easy to convey how it went. But I want to talk about some other workflows going forwards, and like I said in the talk, wireless workflows. But first I want to talk about what makes a workflow. So first, it's installing CircuitPython. So how do you get CircuitPython installed? Which we did by dragging the UF2 file onto the boot drive. And then it's about 2 things. File system access, so how do you see what files there are, and editing the code.py, but also transferring files such as libraries, which I didn't show, but you could drag and drop it just like a USB drive. And then the other component of what I consider a workflow is once you have it installed, is print debugging, figuring out how to get the serial output and being able to see it, see your exception messages and things like that. Beata says USB UART dongles and cables often don't have a serial number programmed in. Thankfully, USB microcontrollers do have a serial number. Fun fact, the RB2040 does not. All of the RB2040s are literally the same. It reads a unique number from the flash that it's paired with, which is interesting. And I think RB2040 is the only one that's like that. But yeah, interesting little tidbit that they don't have unique IDs for RB2040s. Last I looked. Could be different now. Okay, so that's what makes a workflow. Now, what considerations do you have for a workflow? Well, you have to figure out what to what. So this USB workflow is great, but it's only great if you're connecting a desktop and laptop to a device that has USB on it. David says, pause the presentation to answer a question. David says, I'm interested in built-in keyboard workflow. Many existing have a keyboard and a screen. See the issue about press enter to enter the REPL. Yeah, I thought I was going to touch on this, but I don't think I have the time. And I saw the issue for the press enter to enter REPL, and I think there's a mismatch between what constitutes a built-in keyboard. In my mind, it's USB host with a keyboard, and like in that case, press enter to enter the REPL will work because the supervisor, like CircuitPython code's running the USB stuff, not user code. But if you're doing an on-screen keyboard or you're doing like an I2C keyboard, right now those don't work because it's user code that's running those. Okay, so the thing to think about is what to what, where are you starting on, and what are you, or how are you connecting the two things? Phones and tablets are really interesting to me. I did this talk 4 years ago at PyCascades about how folks start in computing with mobile devices now, and we really should think about that in terms of programming and coding. And the USB functionality of CircuitPython, you're still tethered. You'd still be tethered between a phone and a clue, for example. It does kind of work on Android now, but iOS it doesn't really work, I don't think. It's hit or miss. Your mileage may vary. So there's other connectivity that I want to take into consideration, and I've added some notes here about CircuitPython versions and what chips support what connectivity. I don't want to hash that out, but we covered USB, and then the two additional things that we added to CircuitPython. We used to be very strictly native USB because people ask, and they still do, where's my CircuitPy drive? Which is awesome that has become the way to do it. But there are really good reasons that you don't want to just do USB. BLE is great because iOS and Android have really good support. Also means that you're using a phone or a tablet, you don't actually have to have a wire, which is great. It's also great because it doesn't require any third-party or like a third set of hardware. It doesn't require a router like Wi-Fi does. You can just do it from one device to another. So it's great for on the go. And then Wi-Fi kind of like came after our Bluetooth stuff. Wi-Fi has some challenges about like how do you do that initial setup, which we'll cover. But it's really good, especially kind of if you're at home generally, where you have a lot of devices that you're managing and they're all on Wi-Fi. It can make it really easy to do that. So let's do a tour. We'll start with Wi-Fi, but I also want to kind of keep track of the status of the things that you can do between, given a particular set of connectivity and the devices that you're connecting. Beata says, I will be doing a not having a wire project soon. Yeah, and there's definitely reasons to do that. Like Lamore was doing the kids toy I have behind me here. I actually soldered it up, but where you have an enclosure where you don't have USB access. You might be able to do it once, but you can't do it after that, which is why actually I split out upgrade from install. So like you might have to install once, but maybe we could come up with a way that you can upgrade CircuitPython without having like USB access. That's why I split out install and upgrade here. So we have install, upgrade, we need a file system, we need to edit code, and we need print output. So I've kind of got this matrix here, and I'm now kind of like after at CircuitPython 7, we're adding Wi-Fi and BLE to this matrix. So let's do what we did for the USB workflow, but now for BLE and Wi-Fi. Now the fundamental challenge here is that, I don't know what my next, I have two. So let's talk installing CircuitPython for these. So USB is easy. I showed that with UF2. You drag to the boot drive, it works really well. There are a few boards that have Wi-Fi or BLE but don't have access to USB serial, which I think I covered in the last slide but didn't talk about. where we have a circuitpython.org installer for supported boards, and then BLE, there's no real way. There's no real way to do, or the way that you can install over BLE is kind of custom to the board and what bootloader it has. A bootloader is a term for like a piece of software that runs when there's no other software, or you get in a certain mode so that you can load another piece of software. I didn't know Wi-Fi was on the table too. For CircuitPython? Oh boy. I think Wi-Fi is more popular than BLE, for sure. For sure. More people are using the Wi-Fi stuff. This is something I have to work on during the stream, is the Wi-Fi side. So I want to do circuitpython.org installing without boot. I have screenshots for all this. I have not put them in the presentation. Blah, 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 blah. We did these things. And you end up with a settings.toml that includes your Wi-Fi SSID password and an API password so that you can edit code. And then here's how you edit code, which I think I also took screenshots for, but I don't have in here. So that's like our story for Wi-Fi and on how you interact with it at a desktop. Programming over Wi-Fi, to be clear. Yeah, we'll do that in this. We'll get to those pictures. I went through it and I took a bunch of screen grabs for it. I just haven't put them in the presentation yet. So now that we've covered kind of the Wi-Fi story and desktop, let's move on to mobile. This is where it gets really tricky because you need native apps generally. So I don't have slide numbers. I could turn them on. This is slide 37 of 58 right now, but it's going to be probably more like 100. It's a 25-minute talk, but I feel like when I'm doing like sequences, it's going to go pretty quick. Okay, so let's talk mobile. So we use a number of mobile apps to give you all these components of different workflows. The first app that we have here is called File Glider, and this is the BLE FeatherSense LED glasses controller. When do we get LTE workflow? After you add it? No, I don't know. Cell could be cool. I mean, that's kind of getting more where the startups are going. 30 seconds per slide feels good. No, I mean, when I'm flipping through how things work, it's going to be a lot faster than that. I've been using kind of Clue as the reference platform. There's the Clue. Okay, so File Glider is one app that we have available both on iOS and Android. And its goal is to give you access to the file system and the files on it, a basic editor, kind of like we have for web workflow that's not actually in the presentation yet. And then also hook the file system of your CircuitPython device into the OS. So iOS and Android have ways of like apps providing file systems. And so File Glider does kind of those two things. So let me show you, and I have to add slides for the latter part. So how does File Glider work? I need to add a slide here on how to connect up. But you can get a list of devices. And then when you find a new device, you got to get it real close. So you hit the reset button when it's blue, which I have a picture for. I have not made a slide yet. So the 70 BA up here is the new one. So we'll click that. We'll pair to it. And then once we're paired, we can click the Explorer. And now we can see a list of our file system. If we click code.py, we'll pull up there. And this is actually some test code that I had on the device that I was testing this with. But you can actually edit it, and you can hit the save button, and it will save and reload just like the USB workflow does. So that's File Glider. There's a little more I have to add to there about how it does the file provider stuff, but there's actually a bug. So it doesn't work right now, unfortunately. And this is a theme that you'll see at least in our app story. Second, we have, okay, how do we get the print output? So we have a separate app that kind of existed that predates this, that we kind of added the functionality to. It's called Bluefruit Connect. It's also available on Android and iOS. Once you're here, you can get a list of devices, And the CircuitPy 70BA is there again. So if you hit connect with that, you can see the device and you can see the CircuitPython. You can tap CircuitPython and then you get your REPL. Just like in the TO case, it might not show anything, but if you hit the text enter box, you'll get a button for Control C as well. So you can do your Control C, Control D dance a little bit to get it to send you stuff if you need to. So that's how you get your output from BLE or over BLE. I just wanted to quickly talk about PyLeap. This is kind of a third complementary app that's meant to get you going really quickly. It gives you a list of projects that you can install on the device. Unfortunately, I don't have a picture here because it didn't work for me. So we're working on it. But the idea is that you don't have to do, like, generally people don't start with a blank page when it comes to programming, at least when they're early on in their kind of programming experience. You start with a project and you modify it from there. So PyLeap's goal is to get you kind of jumped into a project, and then you can use something like FileGlider or a third-party text editor through the Files API to do the modifications that you want. PyLeap is also on Android and iOS. So, whew, that was a whirlwind. I skipped all the web workflow stuff because I haven't added it to here yet, but this is kind of where we stand in terms of what we support over what connectivity and from what host device. And I see some question marks there that I didn't, I think I meant to move that. Yeah, so I have to move these slides. So we'll do that in just a second. So this is all built on like kind of workflow APIs that CircuitPython has that I also have to add to the slides. But if you want to know more about those, we have a publicly documented Bluetooth services API, and we have a publicly documented HTTP API. And I think this is really cool for this PyCascades audience because you can build more apps, more tooling on top of these APIs to further enhance like wirelessly programming CircuitPython. So here's where we are at the end of the day. Most things kind of are implemented and work, but the reality is that a lot of the wireless stuff still has lots of bugs, which is kind of why I'm coming to you all. We have this problem that it's a lot more effort to wirelessly program because there's no standard protocols between things. There's no kind of standard apps that work on those protocols. Like USB, we kind of like got a ton for free, which I didn't fully appreciate until we went into Wi-Fi and BLE land. So we have a lot more that we have to do to get these workflows going. And then on top of that, because these are new workflows that people don't really expect to use, we don't have a lot of users. And so we have this chicken and the egg problem where we implement something, but not a lot of people use it. I come along to do a presentation and it turns out it doesn't work, or somebody else tries it, it doesn't work. We actually have to, we don't have that feedback cycle of like, oops, we broke it, and it's getting better and better because we don't have the people using it. So what I'd ask is for folks to try it, to use it, and when you find issues, help us fix them, file issues, and write new tools on top of it. It'd be really great. So yeah, wirelessly programming CircuitPython. It's possible, but it's buggy currently. We need more people doing it. We need more people helping. I do want to thank the folks that have done the work so far. It's been a huge amount of work. Antonio and Trevor worked on the mobile apps, and Melissa's done all of the code.circuitpython.org stuff. So help those folks, help me, and let's make CircuitPython accessible over the air or wirelessly. Here's some links, link to the presentation, and that's it. How long was I? Did anybody time me? Don't tell me it was over 25 minutes because I'm planning on adding all of the Wi-Fi web workflow stuff. So you want a slide where that hello PyCascades, so it looks like the continuation of earlier slides. Do anybody have feedback so far? I think that was more like 10 or 15 minutes, which is about right. Ooh, the temperature is going down a little bit in here, which is good. Nice thing is I can practice this more next week. I really just have to get my slides close. I'm gonna like not hold myself to not changing my slides at all. Oh, for BLE workflow capture. Yeah, doing the Hello PyCascades thing again. I thought about that. That's a pretty good idea. I don't know if I want to capture all those screenshots again. Hard to say how long it was because of the pauses. Yeah. I'll be able to tune it. I'll be able to tune it next week. Like, I've got all next week to work on this too. I just need to get them slides by Sunday. All right. I think I should work on this. I got more work to do to get the slides done. I think it felt pretty good to me though. I felt like I had a structure. It felt like I had a message. I felt like, even like with Timon here, it's like, oh, I didn't know I could do that. Like, that's also what I want to bring to this, of just like, I want to bring awareness, and that's why I'm trying to be really thorough about like, here's all the steps you take to get to these things. Fire extinguisher is at 2635 and the last status table was at 53. Uh-oh. That's a lot. The other day, Lady Ada commented on trying to move to one USB stack, and perhaps there are some test cases for USB. How are the various stacks tested for regression purposes? Using a thing called marp is 26 minutes. Oh, don't tell me. I might have to think about this, how I'm going to shorten it. That's kind of why I was like, okay, it's okay for me to just comment on PyLeap. Yeah, it might be too long. There are not good tests. That's the gist of it, is that like a lot of our testing is done through folks using the stuff, which is not all bad, because if things break that no one uses, doesn't matter. It only matters if you hope they will use it, like in this case. But yeah, the USB stack thing was like something we did early on, because like we had done the SAMD21 with ASF3, and then they announced ASF4, and we had to move to that for the SAMD51. And then we were using the vendor USB stacks, and I like found like a couple bugs in the ASF4 USB stack. And the vendor stuff tends to have licenses that say that it can only be used on the vendor's microcontroller. And I was realizing that like all of the like USB class level stuff was shared. So that's why we did the work to move to Tiny USB. It happened to be that like Tak had done this project that wasn't very popular and he did in his spare time, but I was like, no, we'll use that. And then it's gotten more and more popular and busier and stuff. So there's definitely a case for BLE doing the same thing. It's on my radar of like, there's a lot of BLE code that should be shared between different vendors. Someone says ASF4 was also insanely buggy as a whole. Yeah, we still use it. We use ASF4 still. We have our own forked version that has some fixes, but yeah. And then after ASF4, like Atmel got bought by Microchip, and yeah. David says, is it really broken if no one saw it? Not everybody reports bugs. Some just try something and do not return to CircuitPython or that particular workflow. True. Yep. I mean, I think that was partly why I've been disheartened, is like I was trying to get pictures of like PyLeap, and I was trying to get pictures of PyLeap, and I was trying to get pictures of the like file integration, which I do want to put in there. I think I want to own it. Like it just gave me a loading screen and never loaded. Timon, we do all the code I wrote. I generally just use the struct headers for the registers, but there is other code there that uses the ASF4 stuff. DCD says, I think about how Perl, Python, and some libraries are tested, but if there's a way to partition the stack versus Python testing. Yeah, it's really hard. Like cross-device testing is really hard. ADC HAL is completely broken still. You can only read channel 1 on any chip because the ADC mux function is just not implemented. Yeah, I don't know how we do that. I mean, we have the ADC mux working, but I don't know how it's implemented. I think like I was looking at like UART was using ASF4. And it's probably not even the latest version of ASF4, whatever the last one they did is. It's not worth updating. But that's like after getting burned by ASF, I kind of like biased towards not doing that. Although that's not fair because like with the ESP IDF, we use all of their HAL stuff, which has really benefited us. Like it takes some effort to get from version to version, but it's pretty easy to support new chips then. So vendor support matters. Okay, I've got more work to do. No, there's definitely cases where we actually use ASF4. I just don't know what they are. Yeah, don't get me started on better SDKs. 20 onion layers deep. Yep. I mean, even like, yeah, there's usually a few layers. I think there were other distractions during the slides. You can make it work. Oh, thanks for the vote of confidence. I think I can make it work too. I think you're right. So this is what the presentation file looks like. And if you go to that link I showed at the end, you can actually follow along as I edit it. Like I have a github.com/chandnewt/presentations, and that's where all the source files go. And I usually dump like a PDF version of the presentation there too. Okay, these two I wanted to move. So I think what I want to do is I want to leave the Bluetooth stuff to last because I want it to be kind of transitioning into like, yeah, there's bugs and we need help. I acknowledge it's a very hard problem. Yeah, 25 minutes. I had 25 minutes for my last slot, and it was also 21 minutes. I don't know how many slides that presentation was, but it's definitely a very different structure and format than this one. This one is very much like I'm hoping to get you through every single step, and sometimes there's a lot of steps. Unfortunately. So like installing without boot, I captured already. So if we go here, oh, so I want this one. And I want these as well. So this one I'm going to rotate. Actually, no, I want these three. And I'll do a PyLeap one too. It's kind of my MO to like show stuff that doesn't work. Hopefully people take pity on us, maybe. So the one thing annoying, so these are just pictures taken with my phone. One annoying thing is that I gotta convert them. Just, not the end of the world, but I like that I got a picture of it. rotated, but I need to rotate it some more. View, show editing tools. Save. And I want to put that in the slide that is before mobile. I have 5 minutes to do it. Blue, link. One thing that's cool, so I have marp running. I don't even know what what thing it's running in, but it will auto reload here. If you do it right. So that's not right. Oh, I got my exclamation point in the wrong place. And usually when I'm like on a smaller screen, I can maybe I'll do that after this one. It's annoying, like all of that text on the right hand side I'm duplicating, which is probably going to come back to bite me. But so open your File Glider app. You won't see anything listed, but then you tap when it's blue, blinking blue. It'll also be a rapid blink if you don't have color for some reason. It'll just be, there's 2 blink periods at the start, and the faster one is when it's for Bluetooth. And then it'll discover, and you compare blah, 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 blah. Let's actually, while we're here, let's do the other ones too, because I brought those over with me. Call this files 0. My descriptive names. So at the end of the File Glider section, I'm going to do some more. Huh. It was the Control-C that messed up my cursor. There's a glider 5, so this is going to be files 0, files 1, 2, and it is picky about spacing. Okay. Okay, the other thing File Glider can do is I'll add an arrow to this image. You can click Files, and then in Files you have a glider location. So this interfaces to your file systems. You can see all of the different devices that File Glider is connected to, and tap that. Unfortunately, that is a bug. So let's add a bug. Files 3. Bug, and let's get our little my wife was saying how we got this new finance app, and it's all about like using emoji categories. And I'm like, oh yeah, that's definitely my style, is like black and white text with emojis. And just shifts it, but that's okay. Okay, so let's edit those. Let's edit those images while we're at it. And the thing that I've been liking to use is called spectacle. File 0. Ah, you can't see. So the only way to open an existing file in Spectacle is to use it from the command line, which is kind of silly, but the annotation is really nice. Okay, so we added an arrow there. And it pops up in the middle there every time, and I'm not sure why. So if I forget, sorry. Glider. David says, should you downgrade to show glider when it's working and just saying there's a bug in 9.0? I tried the PyLeap thing in 8.2.10 and it also didn't work. I'm not sure what, I'm not sure why it doesn't work. I realized that file glider doesn't file glider wasn't updated for the JSON change in 9.0. I don't think. So one thing I might try to do next week, it shouldn't be too bad of a change, but I'm also I just need to engage with Trevor some more. Trevor should be able to fix it. Okay, there's 1, 2, and we'll just do our device. Okay, so let's take a look again. Oh, and it only auto-reloads if you change the thing itself, so. Okay, the other thing you can do with File Glider is if you open the Files app or any other app that uses the Files API, you can now have a location for Glider. It lists your devices, and then you can list the files through there and use it in some other app. Unfortunately, there's a bug, and it doesn't work right now. But hopefully we'll get it fixed soon. So that's the file side, blah, 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 blah. Okay, the other thing I wanted to show was I did the Hello PyCascades thing on the web workflow. So let's find those pictures and we'll do the same thing. Those are going to be in the screenshots. And so here you can see, here's the web workflow stuff. So I want this. Some of these I already annotated. These ones are the -1s end up before. So I want the -1s, I think. Yeah. Yeah, see, I took all these pictures, all these screenshots already. I don't know if I need all of them. They're kind of hard to see. There's a lot of steps to the install stuff, but let's not do that one. I think I'm seeing the end of the light of the tunnel. This is a lot more stuff to add, but I think I'm seeing the end of the tunnel in terms of like what I want to add, which is good. I don't want to add absolutely everything, and I feel like I'm like running out of time. Like I'm gonna fill it up. As you know, watching my 2-hour-long streams, I have more trouble being concise than I do being long. As always, if folks have questions, feel free to ask them. Okay, web install 0. It's annoying that it jumps it down. Web install. It crossed my mind to actually make a Jinja. Two? Yeah, 2. 3. 4. Do people like the format, or am I going the wrong direction? I think it's probably too late to, don't tell me. Maybe too late, but. Lots of. Seventeen steps to the web install. But it gets you completely on Wi-Fi, which is cool. Okay, and then I'm going to do... I'm just going to do this as ww0. WW for web workflow. Perhaps cover one workflow in more depth with the least bugs and just let the listeners imagine the other workflows. That may be what you're doing already. The problem is the one that works the best is USB, and that's not really what I'm trying to highlight. In my proposal, I gave 10 minutes for 2 minutes for a CircuitPython introduction and like 8 minutes for 8 minutes for like going over what a workflow is. I have an Atari 800. I think you have web problems. I want to use web workflow for my Atari 800. I went a little crazy getting things that had cartridges on it because I wanted to make, like I had the Game Boy cartridge, I wanted to make more than just Game Boy cartridge. WW3. I mean, I can always make the presentation too long. I can put all the slides in and say, here's at most all the slides I'll do, and then if I run it and I'm out of time, then I can figure out how to trim it. Sounds like you don't think I can talk fast enough, which is probably not the right way to go about it, but still. Okay. Oh, you know what? I don't have a picture of the serial. I don't think I have a picture of the serial. Darn it. Let's all add this and then we'll see. I can reference it too. I already have some code. I'm gonna just keep renaming this because that's the groove I'm in. Code CP0. Code CP1. Include links to learn guides for the workflow. That's a good idea. The other thing, link-wise, I'm thinking of including is like links to all of the source repos. If you remember right, this is kind of like the talk version of my CircuitPython 23 post, like blog.adafruit.com. Like that's how long we've been at this. Text search is very slow on the blog. But if you look at my CircuitPython 2023, like, maybe this is what I should include, actually. I should steal this. GIF, actually. Because it shows it working. I don't know why it doesn't work. I'm going to do that. I don't know why they moved the buttons to the top. Oh, and yeah, see, this is the file glider working. Yeah. Yeah, but if you've seen it before, here we go. Okay. So instead of doing an like a lot of these slides are just not animated GIFs, right? Like there's sequences of screenshots so that I can kind of like control and talk over how it goes. I see people using GIFs and then like they don't pace well. So that's kind of why I'm okay with it being like a bunch of stuff. Let's just add that PyLeap one in there while we're at it, though. But yeah, that was part of my working theory on how I structured it, is that a GIF would not pace with me like having a bunch of slides. Okay, all right, so we're up here. We're in circuitpython.org, and we did, we want to do the install series, and my cursor's still broken. Do I sound like I'm ready for the weekend? Like I feel? I call it web install, right? Congratulations, you suggested the same thing. 64 pages. Okay, yep, that's the first slide. So you go to circuitpython.org, don't forget to scroll down, blah, 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 blah. I need 17 of those, I think. Two, three, four, five, six, 7, 8, 9, 10. I'm probably off by 1. And of course, it doesn't like it when it's... My cursor is broken. Oh, you know what? I was going to check it with the neighbor. I don't like that my cursor is broken. But they just told me it worked in GNOME and that was fine. And I'm like, yeah, it's annoying. Here, I can fix it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can count to 10. But sometimes he skips 3. He's still learning. He'll say 1, 2, 4. Like, no, you need 3 in there. Silly. All right, let's see how that looks. Ah, Minnesota Mentat. Sorry, I missed. I'm a little late. I had a window over the YouTube chat. Asked. I'm curious if you're sleeping well enough with the baby. So the baby is 2. He turned 2, which is super exciting. He actually did not sleep very well last night, which is probably another part of my problem. I went to bed later than I should have at like 11:30, and while I was brushing my teeth, he started crying. So I was up till 12:30, and then he slept till 5:30. And then started crying again. He's like, we think it's an ear infection, but it could be teeth as well. So generally he sleeps quite well, but and generally the problem is me getting to sleep in a timely fashion. 2, that doesn't seem possible. I know, it's wild. It is wild. He's potty trained pretty much. I mean, he has accidents still, but he's out of diapers too. So yeah, that is the link I splashed earlier. Thank you. I will commit and publish to that when I'm done. When I'm done here. Okay, let's check the slides. Okay, so there are some cases where we want to use wireless workflow, but we don't have full USB support, so we can't do the boot drive. So I just wanted to run through. We have a cool installer that I don't think a lot of people know about that I just want to run through real quick. So if you're running a regular ESP32, you're running an ESPC something, where you don't have full native USB, this is how you can install CircuitPython. And also, Wi-Fi has this additional challenge of getting your credentials set up. So getting your settings, or getting your Wi-Fi SSID and password is something that we assume that you do when you're connected, when you're wired and connected, when you're getting CircuitPython installed. So here, we're back at circuitpython.org. This time we're doing an S2 feather. We got to scroll down to see this nice open installer link. Once we click that, we'll realize we're in Firefox, and it uses webserial, which the Chrome-based browsers use instead. So we'll switch from Firefox to Chrome, and now we have an option to do a full CircuitPython 9.0 install, so we'll do that. Note, you can also just install or use this to update your Wi-Fi credentials. You don't have to do the full install. There's all sorts of different things you can do from here. Warning, it's experimental. Let us know how it goes, but generally it works pretty well. Next, you have to get your serial connection going. So you hit the connect button. It'll prompt you. Make sure that you don't have TO or something running in it already. Oh, and this slide is blank, 44. How do I know which slide is 44? I wasn't too far. Let's look at my folder. Web install 1, 2, 3, 4, 5, 6, 7. Did I typo any of them? Oh, there's no 8. Okay. Note to self. Missed 8. Okay, go back to here. Okay, so make sure you're not connected, reconnect, and then this will overwrite everything on your feather. And there's also this cool little icon here that shows that it's using webserial. Beata says, switch from webserial to something that runs on more than one browser. For this install process, you can't really, because the board itself is only serial over USB. I don't know what that might be. I'm still using wget and curl. For the install process, I don't think there's a lot of options, but there's definitely like upgrade stuff that we can explore. So it gives you a warning, and once you click that, it erases the flash. It loads the new firmware. This board here actually does do native USB 2, so it has you select the boot drive. Then you can edit the boot drive, so it's cool. The browser can actually edit folders too. And then this installer is using UF2, which is kind of silly. Once it pops up, you'll then give it access to CircuitPy, and now is when you enter your Wi-Fi SSID and credentials, and then it's finished. What that's done is, although this is actually using kind of like the native USB workflow into the hood, it ends up giving you this settings.toml file, which you could add yourself, but it has these keys that tell CircuitPython how to get on the Wi-Fi and what password to use when you're modifying files. It's just not super secure. Don't use a super secure password, but it's meant to kind of like put one small barrier. If you have like a classroom full of kids, one small barrier to kind of prevent easy harassment across devices. So this doesn't go yet. The bit with selecting the UF2 drive name never works for me. Always says wrong drive name. Selecting the UF2. Huh. I don't know why that is. So I need to add more slides here. This is where I'm going to add even more. I think that went pretty quick. Settings.toml, that's what we end up with. And now we're going to put more slides. And these are the WW slides. Maybe I should have used something that didn't have native USB. How many WW slides do we have? This is kind of why I had this naming convention, up to 6. Okay. 0, 1, 2, 3, 4, 5, 6. Let's go back to the presentation. Oh, and you know what? I want a slide between that is circuitpython.local. And let's do HTTP. No HTTPS. Okay, so now we're transitioning from the install process to the... Tyus says, selecting the UF2 drive and boot drive should have been fixed very recently merged, so try again. Maybe only one is fixed. Windows didn't return drive name for me. Ah, and it's already fixed. Great. Hopefully. Hopefully that's what you're saying. Okay, so once you have that installed, you boot it back up. If you have a screen, it should show you that you're on the Wi-Fi. If you have a serial terminal, it'll show you in the terminal title bar that it's on the Wi-Fi, what the IP address is. But if you have NDIS working, which is also used to like discover printers and Apple TVs and stuff, uses a thing called multicast DNS. What you can try is you can try circuitpython.local in your browser. Make sure you're using HTTP, not HTTPS. And what that'll do is it'll take you to one of the devices you have on your network. All of them respond to circuitpython.local, and then immediately redirect you to their specific local domain. So in this case, you can see I have like cpy37, which is like the MAC address, .local. So this is kind of the landing page. This is an HTTP server that's running on the device, on the CircuitPython device, run by CircuitPython, not by user code. Gives you some information about the device, and you'll see here that it also discovered all of the other devices on the network for you. So you can click the other devices to get to that. Like, you have no guarantee which device you get to via circuitpython.local, so that landing page will give you links directly to all of the other devices that it can find via MDNS. It's also helpful if you don't have MDNS on your computer. You can type in one of the IP addresses, and then that CircuitPython device can do MDNS to the others. Anyway, so now we're at a different circuitpython.local. We can click the file browser, and once we do that, we actually get prompted for that password we set in our settings.toml. You leave the username blank, but fill in the password, and once you do that, you'll get a listing of the files. This is all hosted from the device itself. There is a CSS file that loads from the internet just to make it a little prettier, but it's functional without it. You can see code.py is here. What you can do is if you eject the CircuitPy drive, it detects it's ejected, and it will, if you refresh the page, it'll allow you to edit the file. So you can rename, delete, you can upload files all through this interface. You can see how much disk you're using. And once you hit edit, you get to the super basic but offline capable editor here. You can see we just have the print hello world. And you could hit save. But we have something better. We have code.circuitpython.org. MDNS seems to bind to a device that isn't currently running. Someone says, really need to check that out. That's very cool. Okay, so let's go even further. Now if we're doing code.circuitpython.org, you can go here. That is the MDNS that I'm referring to, multicast DNS. That is the right Wikipedia article for it. So if you go to code.circuitpython.org, and you'll probably want to do this in Chrome for the same reason with the loading, but you can have Wi-Fi, Bluetooth, and USB connectivity from the web editor here. And I have to put those slides in. The way that you do it with Wi-Fi is a little tricky because the domain is not circuitpython.org. So let's grab, what did I call those? Those are code CP 0 through 4. I do feel like I missed the webserial thing, which is kind of unfortunate. Like, these slides are going pretty quick though, right? Like, the workflow works for me in Firefox on Windows, by the way. The Wi-Fi stuff will work. It's the web serial and the web Bluetooth that won't. Oh, it won't work in Firefox. I'm a daily driver of Firefox, but I always have an install of Chromium. And in fact, there's like somebody who does a version of Chromium that's just with all of the Google calls removed. It's called ungoogled Chromium, and you can get it on like through the Arch package manager. To me, it feels like it starts up faster, but that could just be my bias showing through. And I think we wanted 6. No, 4. Okay, great. So we're going to save that. We'll go back to the presentation. Okay, so this you can use for Wi-Fi, Bluetooth, and USB. I'll show you the way that you do it on Wi-Fi. So because we had domain restrictions, trust me, we tried to have it crosstalk, and browsers don't let websites talk to .locals. So what you can do is you can take your CircuitPython device, whatever cpy.local, and add /code/. And what this does is it assumes you're online, and it downloads the same JavaScript that runs codes.circuitpython.org and kind of like fills it all out for you, so that you can work from a browser on Wi-Fi. So you do that. It will also do the more network devices for you, and then you can let's see, close, and then if you hit open, you can see a list of the files. You can select the code.py. Here's code.py. You click save and run. Save and run opens the serial side of that connection, that serial print output workflow thing. And now you can see that it has hello world on the right. I switched it to PyCascades 2024, and now after hitting save, we can see that the output is there as well. Whew. I think that's it. I'm missing the web serial, the offline web serial thing, but I think I can skip it because I just showed it through the like code.circuitpython.org version. So this is all the Wi-Fi stuff. I added this like click when it's blue pairing thing. I think maybe I should replace this like David was suggesting. But I think that's... Oh, you know what? I need 2 screenshots for this behind the scenes. Behind the scenes. You know what? I might not do this. I said it would be 5 minutes. I'm not going to do that though. I think maybe I'll just talk about it. I think I'll just have 2 slides for it. I don't think I'll do screenshots. Let's work on this. I'm almost done. I'm almost done, and I'm almost out of time. If folks have questions about anything, it doesn't have to be presentations and slides. Now's the time to ask them, because I will get out of here right at 4. But I think I'll just flush out this slide. So Bluetooth services. is a how bad is the documentation link? Do I have any other docs dot workflows? What tool did you use to convert the MD file to the browser? That is marp for this. For this one, the old one is deckset. The previous one is deckset, and then marp is like heavily inspired by it. marp.app is what I'm using. Deckset's what I used to use. Marp is heavily inspired by deckset, but is open source. It uses like NVM. Okay, so I want this link. And my cursor's busted again. Should I like add this stream to my bug open with the Sublime Text people? Come on, help me out. Serial Nordic UART service, but with different UUIDs. Custom file transfer service. Access and a web socket for serial output. And let me use my little coder emoji and app source. iOS, Android, Bluefruit Connect, and I need to find these. And the last one was PyLeap for iOS and all right, let's find those links and then we'll call it for the day. And I think that, was there any other major thing that I wanted to add? I don't think so. I might shuffle them around. They'll get the idea of what I'm doing. Like, there shouldn't be any copyright issues with like screen grabs that I'm taking. Okay. Let me just. Where's this? I think I have all these links in here as well. Yeah, learn guides, PyLeap source, copy link, iOS. Copy link. I don't think I have File Glider iOS. I'm not sure I have the Bluefruit Connect stuff here, which is part of the reason I wanted to include it. File Glider and File Glider, and now we go. GitHub, Adafruit. Sorry, it's easier for me to look over here. Bluefruit Connect. Okay, here's the iOS app. And the Android app. I think these are right. All right. Good, good, good. So now, if we look at our presentation. So, oh, I love, my millennial brain is tickled by my coder emoji. Behind the scenes, we have workflow documentation. Let me call that workflow documentation. Documentation's a little vague. Workflow documentation, we have for the BLE workflow, we have serial over what's essentially a Nordic UART service, which is really common, but we changed the different UUIDs. That allows the user to create a Nordic UART service. We have a custom file transfer service protocol that is documented on GitHub. Hit the workflow documentation and that links out to the file transfer service stuff. I see a typo. Web workflow, not workflog. I didn't put that. Oh, I did put the GIF in. We'll look at how that looks too. Web workflow, we have an HTTP API for file access and just like that landing page, MDNS for discovery. And then we have WebSocket for the print output serial stuff. Let's MDNS for discovery. Okay. I didn't even talk about the terminal stuff, but I got enough. So that should get people started. And then we'll do app source links here for the File Glider, Bluefruit Connect, and PyLeap if you happen to be mobile development inclined. You can check those out there. So just slow. So here's kind of what we overviewed. The status is we can do Wi-Fi from laptops. We have an API for it, and we can do it from phones. We can do BLE. I don't know if I told this group, but all of the File Glider, PyLeap, and, well, not Bluefruit Connect, but File Glider and PyLeap should work with Wi-Fi as well, which I guess is this Wi-Fi print output one is a lie. It works, so code.cp.org will work, I think, I'm gonna have to think this over again. But Wi-Fi print output on phones is a caution. I think I'll just say it. It's not there. Bluefruit Connect I don't think works with Wi-Fi. So yeah. Last minute questions if you fancy. 1, is Android supported for BLE stuff? Yes. I think we should have feature parity for FileGlider and PyLeap between Android and iOS. But like I said, there are bugs, so beware of bugs. But in theory, yes. And in fact, Chrome on Android does support like the web Bluetooth stuff. So I think code.circuitpython.org should work with Bluetooth on Android devices. That's not true for iOS, but that is true for Android, I think. And then totally unrelated, if one does try using OTA, is there a way to switch apps? Also, is there some mechanism for rollback if the new OTA app is bad? Or does it only have the ability to go forwards? Download a new bin in Flash, hope you got it correct. So this is why I have marked partial on here, is that CircuitPython does have what the person who added it added called dual bank. So there's a dual bank module on ESPs generally that allows you to flash to the other bank and then switch to it. I have not tried it myself, and we don't kind of have it documented, so I don't consider it to be well supported. Like we haven't taught people how to upgrade over Wi-Fi, but that's why there's a little partial marker there. So yeah, it's kind of like you have to DIY it right now. But it should allow rollbacks, except whenever we run out of space on ESP, people come to want to remove that second OTA partition. But I keep fighting because I think at some point, especially as web workflow gets more popular, we're going to want it. But yeah, I think that's it. I didn't look at the animation like I said it was. So status, I think I'm going to remove that copy of the status. I think I'm going to go straight from PyLeap to behind the scenes. And so it is running. But I feel like I need to put the bug warning there too. Trevor is looking at it. I already asked him to. Where did my bug? Okay. Oh. All right, let's wrap up. My brain's gone. My brain's gone. Oh, you know what? Before I wrap up, let's commit it and push it. And yeah, actually, I think I just want all this stuff. Git add dot git push to commit final ish draft. I gotta get this set up better. It's asking me for my GPG key. Which I've got to get from here. I have a secret browser window under there. I don't think you could actually see anything. Hopefully not. Okay, so I created it. I actually, I want to do a PDF as well. How do I do a marp CLI PDF? Look at that, dash PDF. And I think marp is actually running. I have this other weird terminal that I was using for screenshots, and that's where it's running. Let's just close that. Oh, I gotta do the. I tried to install it via the AUR, which is like the user repository for Arch, and it doesn't work then. I just want a PDF. Let's see what's going. It's going to be a giant PDF. I don't think I have it set up to, I assume it's going. Yeah. It's like grabbing all of the 203 megabytes. Ooh, am I over my, how did I get it? How did I fit it last time? I might be over the, I remember, I think it's 50 megs that is the limit for GitHub. Too many pictures. I don't think that's gonna work. Do animated GIFs show up in PDF? I have no idea. Can I do ocular and then presentation.pdf? It loaded. What's it look like? No. Just one frame, which is fine. It works. Git commit, git push. What? Didn't I push it already? Don't reject me, don't reject me, don't reject me. Maybe I had set up LFS already. There's this like git LFS thing for large files. I bet that's what it is. I might have set it up already. Cross fingers, cross fingers. I gotta get out of here. Gotta go home. We're headed to my dad's for the weekend, or for the night. Oh, it rejected me. It's 100 megabytes. Darn. I think I need to shrink all my, if I shrank all of my screen, well, most of the screenshots are not that big. Like all these PNGs are pretty small. It's the JPEGs that are quite large. The gliders are pretty big. I could probably get the PDF size down by resizing these big PNGs. Like they have a lot more resolution than I need. I'm not sure that's enough to get me down all the way to under 100. I doubt. Well, let's see. PDF output options. Outlines. This I can figure out later. As long as I have all the resources, which I do, I can do it from my laptop this weekend. I thought there was an option to compress images in PDFs to the target resolution, like for printing. I don't know how they're generating the PDF, and maybe they're doing that. I don't know. It uses a browser to do it all. Oh, the JavaScript world. Okay, I gotta go. But everything's pushed, I think, enough that I can get something to send them this weekend. In fact, I'll be in town tomorrow night. Okay, the camera. Thank you all for hanging out with me as I work on my slides. I feel good about this presentation. I've got practice to do next week, but I think like pretty much all the images are there. Doing the web or the PyLeap workflow with just printing hello PyCascades is probably a good idea. Maybe I'll do that next week, but not now. Usually I'm doing C code for CircuitPython, not today. The other part of this is being the lead, or at least getting the word out, is doing presentations. So I'm excited to see folks PyCascades next weekend, not this weekend, but next weekend. I won't be there the whole time, so if you are there, please coordinate with me if you want to meet up, because I won't be there the whole time. If you want to support me, you can go to adafruit.com and purchase hardware there, like the clue I showed earlier. Adafruit pays me to do all this, which is awesome. They're a huge support for me, so I really appreciate it. If you want to join the Discord, if you're in the YouTube chat only, join the Discord because it doesn't go away when I click end stream. You can do that by going to the URL adafru.it/discord. I think I'm around next week. And in fact, it's the day before PyCascades, so I will be here. I should be able to stream, assuming everybody in my family is healthy. And thanks preemptively to DCD for taking notes. Usually does. And thanks to everybody who hung out. Have a great weekend. I'll do a little bit of camera, and then I gotta run. Thank you all. Have a good weekend. See my reflection somewhere, somehow it's reflected. But yeah, thanks all. Have a great weekend.